Hello student, I am Arnab Das. Today we meet together for discussing about the topic oscillator. Basically, we discuss today for the review of the basic concept for the oscillator and also the Barkhausen criteria. Though entire of this module we flow in such a way where we describe the basic concept of oscillator, discuss the basic principle of operation of an oscillator, analyze the operation of RC and LC type of oscillator, describe the operation of basic relaxation oscillator circuit. Oscillator basically one kind of circuit where a periodic waveform can be generated, and obviously that periodic waveform is generated without an external signal source. So this is an converter where DC to AC conversion process is going on there. Oscillators are circuits that produce a continuous signal of some type without the need of an input. These signals serve a variety of the purpose. It may be used for the communication system, may be used for the digital system, may be used for the test equipment, for each and everywhere for electronics device. The oscillator circuit is most important one. So oscillator is a circuit where the oscillation process is maintained. Their characteristics are represented as wave shape, that means what type of wave it can generate, how much frequency it can generate, and what will be the amplitude variation can be occurred to that particular oscillator, what is the effect for the distortion, and also the stability. These are the characteristics for an oscillator. Oscillator, basically we know that it generates the signal. Its use as a local oscillator to transfer the RF signal to the IF signal in a receiver. It's used to generate the RF carrier in transmitter, generate the clock in digital signal, used to sweep circuit in TV sets and CR. That means to maintain the visualization or image at the TV or CRO, the most important thing is the sweep one. So that particular arrangement can be done by the oscillator. So we can conclude in such a way, oscillator are the circuit that generate the periodic signal. Oscillator convert DC power from the power supply into AC signal without the need of the AC input source. There a typical waveform is given for the ramp one. To maintain the oscillation, that is to maintain the oscillation process, feedback should be positive, and the relaxation oscillator make use of a RC timing circuit to generate a non-sinusoidal signal such as square signal. So if you look on the oscillator one, that time you can see that DC supply is used as an input, and you got the AC one. It may be sinusoidal, it may be sawtooth, it may be square wave, whatever. If it is not into the form of sinusoidal like square wave, that is this is the relaxation oscillator, that time RC timing circuit is so important one. Oscillator basically classified in this form. One is RC oscillator, where resistor and capacitor, these two important passive elements, are used to design the oscillator circuit. This type of oscillator example is Wien bridge oscillator, and another one is the phase shift. For LC oscillator, where the inductor or capacitor are the most important passive element for generating the oscillator circuit, the examples are Hartley oscillator, Colpit oscillator, and crystal oscillator. The last one is that unijunction or relaxation oscillator, where non-sinusoidal type of periodic signal can generate. So this is the type for an oscillator. For the linear oscillator, their amplification is maintained as a linear one form. That is, the linear oscillator produce an approximate sinusoidal output. And switching oscillator, another approach to oscillator design, it employs the active device as switching rather than the linear amplifier. So I think this is an important point. Again, I just repeat that for the linear oscillator, their approximate sinusoidal output can generate. And for switching oscillator, where it's imply active device as the switching rather than the linear amplifier. So this is an block diagram where you can able to understand what type of performance is going on there. Look at here, positive feedback is maintained in here to maintaining the oscillation process. And for the linear, because the output is approximately sinusoidal, if we consider for the linear one. And for the linear oscillator, the frequency selection feedback network and amplifier to maintain the loop gain and unity is maintained on there. We just go and block view for the feedback one, so it may be suitable for the understanding for the oscillation process.